All right, so today is our final lesson. We're looking at factoring application problems. And before we do, I just want to take a moment to review everything we've talked about, really, with factoring polynomials. It all kind of breaks down to these couple of steps where, anytime you start with a polynomial and you need to factor it, the first thing you should always do is look for that greatest common factor, the GCF. Now, if there is something you can divide out of every single term, whether it's 2 terms, 3 terms, or 4 terms, or whatever, if every single term in the polynomial has a common factor, divide it out, okay, or factor it out of that polynomial. Then check to see what remains. So step 2, it kind of depends on what you have left. If you have 2 terms remaining, meaning it's a binomial, then you want to check to see if there's a difference of squares. And that's really the only other way that you're going to be able to factor a binomial is factor out the GCF if possible. And then there has to be a difference of squares. Remember, that's the one where we had like x squared minus y squared, for example, or a squared minus b squared. If both terms happen to be a perfect square and you have the subtraction in the middle, meaning it's a difference, then you can factor it. Use that factoring pattern from the previous lessons. If it's not that, then you're done. For example, if it represents x squared plus y squared, there's nothing more you can do with that. Okay, so usually when you get down to a binomial, there's nothing left. After you check for GCF, of course, and after you check to see if it's a difference of squares. Step 2b says if a trinomial remains, so 3 terms left, we use the area model to determine if it can be factored. Remember, that's where we are using our boxes. Okay, and we've worked on factoring trinomials a lot in this unit. So we know that that first term goes in the first box, the last term goes in the last box, and we try to figure out the other 2 boxes add up to that middle term of the trinomial. Okay, so we check to see if that is possible. And that's pretty much it. That's going to be kind of the only way. Even with perfect square trinomials, we still use the area model to show that. So even if we have that special factoring, we can use the area model. So let's get into our application problems. We're going to take a look at 3 problems together. And then for today's recommended homework, you'll have more of a review assignment to get you ready for the test, but also there's some application problems at the end of that. And then your quiz today will be application problems, just a couple of them. All right, so here we have, let's see, the area of Margot's laptop computer screen is 12x squared plus 3x inches square. All right, so here's the area that we're dealing with. In other words, that represents our polynomial when something was multiplied together. So we get 12x squared plus 3x. And part A says to factor this polynomial to find the expressions for the dimensions of our computer screen. And then in part B, it says to give the actual dimensions of the computer screen if x equals 4. So, maybe we'll end up with a computer screen that's, 8 by 12 or something like that. But that's what we're going to try to do in that last part. So let's start by trying to factor this expression, 12x squared plus 3x. That's our polynomial that represents the area of the computer screen. Now, factoring means that we'd want to find a length and a width. Okay, so length times width equals area. So let's try to think about what multiplies together to give us 12x squared plus 3x. Well, if we go back to our review for just a second, notice that we have 2 terms. So this is just a binomial. And the first thing we want to do is look to see if there is a greatest common factor. Factor that out if possible. So let's go take a look at that polynomial. Okay, so we've got 2 terms. Now I notice that my coefficients of 12 and 3 can both be divided by 3. So I'm just going to mark my GCF over here contains a 3. And I also notice that both terms have an x in it. At least one x in it. So my GCF is actually going to be 3x. So we are going to divide out the GCF as a way of factoring. We just remember that when we do this, the GCF kind of goes in the front. And let's see, I had a binomial with addition in the middle. So it's still going to be a binomial with addition in the middle. So now I just need to divide some things out. Okay, so I'm going to divide this out and put my answer here. And I'm going to divide that out and put my answer there. Let's start with that first part. So 12x squared divided by 3x. Well, I know that 12 divided by 3 is 4, and x squared divided by x is x. Just as a reminder, that's like, well, let me write it in here first. X squared divided by x. We cancel common factors, and you're left with just the x there. All right, in the second part, 3x divided by 3x, well, I realized there that I'm dividing something by itself. So 3x divided by 3x is just 1. So I have one of my factors is 3x. I'm going to go ahead and put parentheses around that just so you can see that that is a factor. And then my other factor is 3x plus 1. So that would be like my length and my width. So I could say my length is 3x and my width is 4x plus 1. Or it could be the other way around. We don't really know which one's the length and which one's the width. I would assume with a computer screen, whichever one ends up being bigger is going to be the length across, versus the up and down is usually the shorter length. All right, so if we look at part B, give the actual dimensions if x equals 4. So let's go ahead and take those factors. So if my length, one of my lengths, was 3x and x equals 4, 3 times 4 is 12. And my dimensions earlier were given in inches squared. So I would have a length of 12 inches. So I just take my polynomial and I substitute x equals 4. Now for my width, that was 4x plus 1. Remember, that just means 4 times the x value plus 1. So we're going to substitute. The x value given was also 4. 4 times 4 is 16, plus 1 is 17. So my width is 17 inches. So there I have my dimensions of the actual computer screen. The computer screen is 12 by 17 inches. Not bad. It's a good sized computer screen. Here's another example. This time we're dealing with a much larger area, not just a computer screen. It says a plot of land is rectangular and has an area of x squared minus 5x minus 24 meters squared. Now we also know the length is x plus 3 meters. We're asked to find the width. So what it looks like here is we're going to take that area. So we have x squared minus 5x minus 24, and we're going to try to figure out what the factors are, knowing that one of my factors is x plus 3 because that's the length. We're trying to find the width, the other factor. So let's use our area model to kind of plug in what we already know. So we know we're starting with x squared minus 5x minus 24. We also knew that one of our binomial factors was x plus 3. Now, do you think we can figure out the rest of this? Well, knowing that I have x squared in that first box, that's got to be x times x to give me x squared. And then knowing that I have negative 24 in the last box, can we figure out what that number is up above? Well, it's got to be 3 times something that equals negative 24. So in other words, negative 24 divided by 3 is negative 8. So 3 times negative 8 is negative 24. Now we just need to finish it off and make sure that the rest of it works with our area model. X times negative 8 is negative 8x, goes in the top right. The bottom left-hand corner, we're taking 3 times x, which is positive 3x. And when we add those together, we get negative 5x like we were supposed to, that area, the middle term in our area. So it looks like the width of the plot is x minus 8. And that would be measured in meters, just like all the others. All right, so we were given the area and the length, and we could use that then to find the width of that plot of land. All right, here's a third example where we're factoring polynomials. So a rectangular painting this time has an area of 2x squared plus 8x plus 6 centimeters squared. Again, they're giving us one of the sides. The length is 2x plus 2 centimeters, and they want us to find the width of the painting. So just like what we did on the last one, we can start by writing an equation showing that relationship between the area and the length times the width, which we don't know. So let's use our area model to try to figure this out. So in my area model, I have 2x squared and positive 6. And I know one of my lengths was, where was it? The length is 2x plus 2. I guess I'll put that across the top. I could have put it down the side too. I guess it doesn't really matter. But let's see if we can fill out the rest of our area model here. Well, let's see. In my first box, I have 2x squared. So that's going to be 2x times something. I think the only thing I'm missing is another x in that. So 2x times x is 2x squared. That's going to make this 2x, 2 times x. In the last box, I got a 6, and that was when I multiplied 2 times something over here. Well, that's just got to be 2 times 3 then to give me 6. And I can get my last little area here of, looks like 6x, because 3 times 2x is 6x. And when I double check the sum of those two like terms, 6x plus 2x is 8x, which is exactly what it was supposed to be. All right, so it looks like my length, the one that we already knew, I'm going to write that in a different color, blue. My length was 2x plus 2. And my width was x plus 3. So for the width of the painting, just so I can write my answer off to the side, the width was x plus 3, and this was all measured in centimeters. And make sure that we're answering the right part, even though we used the area model there to help us factor. All right, so part B, give the actual dimensions of the painting of x equals 14. Ooh, okay, so if we know that our length, which I use blue up above, the length is 2x plus 2 centimeters. And let's see, x equals 14, so we're just going to use a little substitution there. 2 times 14 plus 2. Let's see, that's 28, and 28 plus 2 is 30 centimeters for the length. It's actually kind of a small painting, isn't it? You're measuring in centimeters. All right, next would be the width. I use green up above, try to match here. My width I found to be x plus 3 centimeters. And if x equals 14, I substitute. It's just 14 plus 3, which is 17 centimeters. So the dimensions of my painting here, the rectangular painting, would be 30 by 17. Not bad. Probably a little bit bigger than a sheet of paper. All right, so that's it for today. You can use factoring as a way to solve real-life application problems. If you know the total area, you can use it to find either the length or the width, or as a challenge, you might even need to find both the length and the width to see how it's possible. And then once you have those factors, you can know a little bit more about the problem like we did in part B, giving the actual dimensions for a given value of x.